Okay, so this is going to be a review of how to do a one sample t-test. A lot of you guys struggled with it. So on your jamovi for that week, for the one sample t-test week, I can't remember which one it was right now, you had to test, the question was about human body temperature. You had to test the hypothesis that it was getting lower, that it was decreasing over X amount of time. And you had to first state the null hypothesis and the alternative hypothesis, and then go through all the procedure. And then I asked you to test a different hypothesis. So what if you had tested the hypothesis that were actually increasing? So we're going to do the same thing, but we're going to use different data. We're going to use midterm 1 grades. And we are going to test the hypothesis that the grades in this class are greater than an average, right? So my last, one of my last classes, their average midterm 1 score was 37.7 out of 50. Okay, this was for a class for several terms ago. And let's test the hypothesis that this class scored better than the last class on the first midterm. Okay, so I'm not testing that it's different. I'm testing that this class did better than the last class. So the alternative hypothesis, which we denotate H sub A or H sub 1, mu, okay, that's the mean. We always make hypotheses about the population and not about the sample. Mu is greater than 37.7, okay? Our null hypothesis always has an equal to 0 in it. It's H sub 0 is mu, so that's mean, that's the Greek letter for the population mean, is less than, so it always has to be the opposite if it's directional, and or equal to 37.7, okay? So that is writing out the hypotheses. Okay, for that, the jamovi worksheet, it was the opposite. It was you were testing that the hypothesis it was less than, but you get the idea. Okay, so we're going to test this by running a one sample t-test. So analyses, t-test, one sample. Okay, so right here we see our test value is 37.7. We are hypothesizing that it's going to be greater than the test value. So a lot of you guys made this error. You either carried out, didn't get the hypotheses right, and you didn't get the right test here. You're not doing a non-directional test, okay? You're not doing just isn't equal, either more or less than. You were doing a directional test. For that assignment, you had to choose this one because you were testing the hypothesis that body temperature had lessened. We are testing the hypothesis that the grades of this class are greater than last. Okay, so we do that. We move this over here. Okay, and there we get the results. If we want the actual grades, so we understand what's going on, we can click on descriptives. All right, so let's look at the results. Okay, first we look at our p-value. 0.965. Okay, this means this is greater than 0.05. We're wrong, okay? And it's wrong, and we can look right here, and we can see that the mean for this class was actually less than. So right there, we conclude we failed to reject the null hypothesis and conclude that this class did not do better than the last class. Plain English, this class did not do better than the last class. Full stop, okay? So I asked you to do that. I asked you to report the p-value, the t-statistic, okay? All that stuff. You might, maybe the mean and standard deviation are here. Right. So then I asked you in the assignment, I asked you if we had hypothesized the opposite, that temperatures had increased, would we be able to reject the null? So for this example, I'm going to ask you if we hypothesize the opposite, that this class did worse than the last class, would we be able to reject the null? So let's test that. So let me erase these guys. And now we're going to make the opposite hypothesis. Okay. We're going to test that they did, this time we're going to hypothesize that they did worse. And let me find, so now we're hypothesizing that I'm trying to, that they did worse. So this hypothesis is simply that they did worse. Okay. That's the alternative hypothesis. We're testing hypothesis that this class did worse. And the null is that they did greater or equal to 37.7. So in this case, we're going to do, we have to go down here and change, we're testing whether it's less than the test value. So we have the same test value, we change that it's less than. Now we look at how things changed. So now that we change it, we can verify that we're testing the correct thing right there. Now we're testing the hypothesis that this class did worse. Okay, that's H sub A, less than. Okay, here we look at the p-value. So we already looked at the mean. We know that it would look like it was worse. And yes, here we can reject the null, okay, because of alpha level at 0.05, our p is less than 0.05. So we can reject the null and conclude that this class did worse than the last class, okay? So hopefully that clears up that one-tailed t-test assignment.